In the previous video, we built a Python script to monitor your laptop's battery and send the data to Firebase. Today, let's take the next step, integrating an ESP8266 and Firebase to control a relay module and complete our automatic charging switch. Ready to bring it all together? Let's jump into it. This is part 2 of our project to build an automatic laptop charging switch. In this video, we'll set up the ESP8266, configure Firebase credentials, and write code to fetch battery data wirelessly. By the end of this video, you'll see the relay module turn on and off based on your laptop's battery level. First, we begin by including the libraries for Wi-Fi and Firebase communication. The ESP8266 Wi-Fi.h library allows the ESP8266 to connect to a wireless network, and Firebase ESP8266.h helps us communicate with Firebase real-time database. Next, we define constants for our Firebase project and Wi-Fi credentials. The Firebase host is the URL of your Firebase real-time database, and Firebase auth is the unique database secret or authentication token. Similarly, the Wi-Fi SSID and Wi-Fi password variables store your Wi-Fi name and password, which means your network name and password. Here we define the GPIO pin connected to the relay module. The relay pin is set to D1, which maps the GPIO pin on the ESP. We initialize the relay pin in the setup function and ensure the relay is off initially. Inside the setup function, we first initialize the serial monitor to log message, then we configure the relay pin as an output and turn it off. Next, we connect the Wi-Fi using Wi-Fi.begin and wait until the connection is established. Finally, we connect the Firebase using Firebase.begin, providing the host URL and authentication token. In the loop function, we continuously fetch battery data from Firebase. We use Firebase.getJSON to retrieve the entire JSON object from the laptop battery node. The JSON object is passed to extract the battery level and plugged in status. These values are stored in the battery level and plugged in variables. The relay control logic uses the battery level and plugged in status to determine whether to allow or stop charging. If the battery level is below 20% and the laptop is not plugged in, the relay is turned on, starting the charging process. If the battery reaches 100%, the relay is turned off. Now let's begin by adding the Firebase URL host and authentication key to the code. These credentials are specific to your Firebase real-time database and ensure secure communication between the ESP and Firebase. ESP host is the URL of your Firebase real-time database found under the project setting in Firebase only. And Firebase auth is the database secret key used to authenticate the ESP8266. Once these details are updated, the ESP can securely fetch and send the data to Firebase real-time database. We have already added the Wi-Fi SSID and password. Ensure these matches your network for the ESP to connect successfully. Double check that your network credentials are correct to avoid connection errors. First, ensure the ESP8266 board package is installed. If not, refer the I button or check the description box for the detailed video. Once the ESP8266 is installed, connect your ESP to the computer via a USB cable. Go to the Tools, then Port and select the port where the ESP is connected. If you are unsure, unplug the ESP and check the available port, then plug it back. With the board and port configured, it's time to upload the code. The coding part is done. Now let's see it in action. I have connected the ESP8266 to my laptop, and here's what happened in the real time. First, we notice the battery rate on the Firebase dashboard. As the battery level charges, the ESP fetches the data and controls the relay module accordingly. Watch as it switches the relay on and off on the battery level. And that's it, we successfully built a smart laptop charging switch using Python, Firebase and ESP module.